Alright, guys. So today's going to be a little bit different, so I'm going to need your attention, and you will need your calculator or a multiplication chart to do these. Okay, so when we're looking at multiplying and dividing, we're also going to be looking at positive and negative integers. So I want you guys to draw the triangle for these guys. Okay, so you're going to have one positive and two negative, and that's going to be what's going to help you answer these problems. Okay, we're also going to use our scale because we're still looking at keeping our equations balanced. Okay, that is still important. This time, instead of adding the opposite, which was that first step that we talked about, we're going to multiply or divide. Okay? When we have a problem like this one that says 3x, that means that we are multiplying 3 times x. So we're going to look at our inverse operation. Okay, we're going to look at our inverse operations. Inverse is kind of opposite, right? So yesterday when we added, the inverse is subtract, or the opposite. When we subtract, the inverse is to add. And this was yesterday. Today, we're going to look at multiplication. So when we're multiplying, the inverse is to divide. And when we are dividing, the inverse is to multiply. And this is very important for looking at inverse operations. I'll give you guys a minute to write that down. Alright, so these are super important, okay? This is what you're going to need to refer to when we're doing these types of problems. So let's go back to problem number 1 there. Okay, this says 3 times x. So what did I say the inverse operation or multiplication was? Divide, right? So I'm actually going to divide both sides. I'm going to divide both sides by the coefficient of x, or the number that is in front of x. Okay. Sorry for my cough. So when we divide in algebra, which is what we're doing now, we don't use the division sign. You guys remember this guy here? Divided by, right? We don't use that guy anymore. That guy is gone. No. Now when we're dividing algebraically, we use a fraction bar. This fraction bar also means divided by. Okay? What we're going to divide by is the number that is in front of the variable. We call that the coefficient. If you ever aren't sure, you look in the back of the room, and I have a nice little poster of an algebraic expression which explains what the name of every term and number and variable in that expression are called. So what's in front of my x today for this problem? 3. So we're going to divide both sides by 3, because remember, I want to keep it balanced. So how many 3's go into 3?
1.
That becomes a 1. But remember Juan, he's shy, so we just leave Juan alone. We let him hide. Because I have 1x, I know that I have Juan x. Okay, there's a Juan there. 1. So now this problem on this side says 18 divided by 3. So you're going to go ahead and you're going to take your multiplication charts or your calculators, and you're going to go ahead and say, what is 18 divided by 3? Huh? Yeah. 6. 18 divided by 3 is 6. So that tells me that my answer is 6. Now, I didn't need to use this triangle today for that one because they're both positive. The only time you're going to use your triangle is when your numbers are either positive or negative, or both, okay? So when they're both positive, we don't have to learn anything new. Let's do number 18 here, and I'll use this triangle for that one. I'm number 2. Okay, so I'm going to draw my line, keep my scale balanced, right? This says negative 3b is negative 3 times b is equal to 18. So I'm going to have to do the inverse. What is my inverse of division again, of multiplication again? Inverse of multiplication is, so I'm going to divide both sides by the coefficient of b. What is in front of b then? -3. Okay, make sure you look at this negative here. And I'm going to divide both sides by -3. -3 divided by -3 is going to be what? 1. It's 1. 3 goes into 3 once. So I'm going to let Juan hide, and I'm just going to bring down my b is equal to. I know that it's b. It's 1b. How many b's are there? 1. So it's 1b. But Juan is shy, so we let him hide. But now I have a positive 18 divided by a negative 3. So it is 6, but I have a positive and a negative, so my answer is going to be -3. Do you guys see how I use this here? I had a positive and a negative, so my answer is going to be negative. All right, we're going to do a couple more with the triangle. I did teach you guys a triangle already, right? Okay, so we're going to keep going. Oh, gosh, you're right. I don't know why I'm thinking 3. He said 6. I said 6, didn't I? I wrote down 3. Who knows? All right, so let's look at number 3. We're going to do another one together. I'm going to draw my line here and keep my scale balanced. This says 7 times r, correct? 7 times r. So how do I do the inverse? What is my inverse then? What am I going to do? I'm going to do what operation? What mathematical operation? The inverse of multiplication is? So I'm going to divide both sides. By what number, Camilla? By 7. Awesome. So this becomes 1, right? That's my goal, to have r all by itself. But I'm going to need a triangle here. Right? So I have, here's my triangle. So I have a -21 and a +7. That means my answer is going to be negative, so I'll write my negative sign. What is 21 divided by 7? So my answer becomes -3. All right, easy peasy lemon squeezy. Yes and no? Yes. Let's do one more here.
But at first I thought that when we first did in first grade, I thought we were supposed to put the numbers inside the
Triangle.
Yeah, like,
no.
All
right, so let's look at number 4. Number 4, okay? There's my scale to keep it balanced, because what I do on one side, I have to do to the other. I have a -7 times p is equal to -42. So I'm going to go ahead and I'm going to use my inverse operation. What do I have to do to both sides then? Divide both sides by what? What?
7.
-7. Camilo, I need you to settle down. All right, so let's go ahead and do this. We know that this becomes 1 and just 1p, right? So I have a -42 and a -7. What's my answer going to be? What is 42 divided by 7? Got it? All right, let's do a couple of the division ones. So flip your paper over to the back side. So we're looking at number 18 now. All right, so we're going to start with number 18 on the back side. This here is written up as a division problem. You guys are used to seeing something that looks like this, right? This says x divided by 10. This also says x divided by 10. That fraction bar becomes our division sign. Okay? So to undo division, okay, we're going to go back to that front side And if I start with division, how do I undo it? I need to use multiplication. Okay? So, excuse me. This, we're going to start out super easy. Remember I told you there's somebody in front of x? How many x's are there?
There's one.
1. So we're going to put that 1 there. And I want you guys to get used to multiplying by the reciprocal. Okay? So I could just multiply by 10, both sides. But sometimes there's going to be a number that's other than 1 there. So I want you guys to get used to multiplying by the reciprocal. The reciprocal is the flip of this fraction. So instead of multiplying by 1 over 10, I'm going to multiply by 10 over 1. And then I make my negative 5 into a fraction. Those ones are just going to drop off, but I need it in order to cancel out these problems and make them all 1. Okay? I'm going to put my scale there. We're going to do this a couple times. None of your problems today have a number in front of that. We're going to get into that in a little bit, okay? So our problem is going to end up being whatever my answer to this multiplication here is. So let's do our triangle here because we still need the triangle, okay? So I have a negative 5 and a positive 10. My answer will be negative. What is 5 times 10? 50. So my answer x is equal to negative 50. My triangle still applies. Okay? Right? A little bit more confusing, but not really. Okay? Again, so what is in front of a here? How many a's do we see?
1.
So I'm going to put that 1 there. And then I'm going to multiply by the reciprocal,
2 over 1.
Which is 2 over 1. And remember, what I do to one side of my scale, I have to do to the other side. Okay? Now I'm going to draw my triangle because that's going to come in handy. And I'm going to cross cancel. This becomes just a. How does this cross cancel? Because 2 times 1 is going to be what? What's 2 times 1? 2. What is 1 times 2? What is 2 over 2? 1, right? Exactly like the other side, we just use cross multiplication to cancel it. We just use multiplication to cancel them. So over here, my 1s are going to drop because anything over 1 is going to be whatever your answer is. So I have a negative 4, didn't finish my triangle, and a positive 2. My answer is going to be negative, right? 4 times 2 then is going to be what? Negative 8. Got it? Yes? Raise your hand if you have any questions. Ah. Okay, show me fist of 5. I totally get it. I can go on and do this by myself. Show me a 1. Maybe I need some more help. I got a couple 2s, some 4s. All right, I'm going to do one more. And then I'm going to set whoever needs to be set free to work on them. Okay, let's do another one that looks a little tricky. Let us do, yes, let's do number 22. Let's do 22. Listen. Let's look at 22. Do you notice this negative sign out in front of here? That means my fraction is going to be a negative fraction. Okay? So I'm still going to multiply by the reciprocal, but the reciprocal is also going to be negative. So negative 9 over 1. Okay? These guys are going to cancel again, and I'm good to have an answer. But I'm going to go ahead and write negative 9 over 1 on this side too. So let's look at my triangle here. Okay. I have a negative times a negative. What's my answer going to be? Positive, right? So since I multiplied a negative times a negative on this side as well, I'm also going to have a positive answer. Right? A negative times a negative is going to give me a positive 1. So my n is going to be equal to whatever the sum of these problems are, and we said they're going to be negative. So 9 times 4 is what?
36.
36. All right? So here we had a negative and a positive, which gave us a positive. And then again a negative and a positive, which gave us a negative. Here we had 2 negatives that gave us a positive. And the other way we're going to get a positive is to look at number 17, which are all positives. Okay? So if I put that 1 in front of number 17 there, I'm going to multiply by the reciprocal, which is 6 over 1 on both sides. This becomes 1n, or just n. Remember, I dropped my 1s. What is 8? Oh, that's a negative. Oh, look at that. I thought that was positive. What is a negative 8 and a positive 6? What is negative 8 times positive 6?
48.
48. All right, any questions? We good to go?